quite there yet. Go down. Actually, I like those pictures of it. I'm gonna leave it right there. All right, everybody. Welcome to Astro-BS. This is Samuel Singer, the founder and executive director from Wyoming Stargazing. We're here at the Wyoming Stargazing office with a few of our stargazing leaders. We got Ryan DiGregorio right next to me, and then Matt Graham, Dave Martin over on the right. And we are just gonna, we're gonna talk a little bit about astronomy and some cool stuff that's happening in the field of astronomy right now. So one of the big announcements that you may have already heard of just in the last week or so is that potential life has been discovered in the upper atmosphere of Venus. Not complex life like us or intelligent life, but maybe bacrobial life. So yeah, let's talk a little bit about that. What do you guys think about this latest discovery?
Well, I think that discovery of, it was large concentrations of phosphine gas, right? That was it, like larger than we'd know to be able to be produced without biological processes. So that's sort of the big deal.
Yeah, so either there's like microbial life there, or we don't really understand chemistry, right? That's a possibility. Right. Yeah. We don't really understand what's going on either on Venus's surface or in the upper atmosphere. But if we really understand those things, then the other possibility is life.
Yeah, which
I think there's a lot we don't know, so I'm leaning towards the we don't really understand. But.
So you think it's just we haven't really figured out the chemistry, and there's no life in the upper atmosphere of Venus?
I think that we know a lot, but like I think that obviously there's just so much that we don't know that I think that it would make sense that there would be countless things about every science that we are just going to get our minds blown the longer things go on. So I think I'd be happy to be wrong, but I don't think that it's absurd for us to think that it's just something we don't know.
Yeah. I mean, so what do you give the chances? You think it's like 50-50? Either it's life or something we don't know, or are you more like 75-25 for chemistry?
I'm definitely leaning. We have no clue what we're thinking, but that's just me. I don't know.
You were gonna say something, Ryan?
Yeah, a thought I had was, what if all the Earth that we have ever observed and interacted with on Earth isn't all possible life?
Sure.
What if it's only a very, very tiny fraction of what any organism could be? And so, yeah, I am leaning also to just incomplete understanding about biology.
Yeah, I mean, we live just about like 70 miles south of Yellowstone, right? And there are extremophiles that live in the hot springs in Yellowstone, well over like 150, 160, 170 degree temperature water, high acidic content, but they're just kicking along just fine. Mm-hmm. So yeah, there could be life that lives in all kinds of extreme environments that we haven't thought of yet.
And also just like think of like we're expecting the gases produced, like we're basically saying there's a chance of similar life on like that we have there. Like,
right.
Like phosphine gas is an indicator of Earth life. Like imagine if like for some reason there's like all these other gases that's created by these other life forms everywhere else, and we're just missing all these blatantly obvious ones because we're like phosphine, we expect it to happen exactly the way it is here, and we could just be missing like huge indicators that we don't even have a clue of.
Totally. Yeah, we can only look for biosignatures that we know of, right? Yeah. There's no way of knowing what we don't know about what other life might look like out there in the universe. But I mean, there is good reason to look for stuff similar to Earth, right? We think that at least elements are universal, right? We were not expecting to find like different elements that exist on Earth someplace else in the universe. There might be different chemical compounds that happen in some strange exotic environments out in the universe. But specifically with Venus, our so-called sister planet, we think that it may have been very similar to Earth in its distant past, and some runaway greenhouse effect brought it to the more hellish environment that it's in right now. And so, yeah, I think there's good reason to look for stuff that we know about, but you're absolutely right. It's kind of like how we learned about the electromagnetic spectrum. Like first it was just visible light, and then some clever scientists discovered infrared and ultraviolet, and then X-rays and radio waves, and the spectrum just kept getting broader and broader to what it is today. Maybe it's similar with life.
I think so. It'd be really cool to find or discover even more complex life than humans.
Right, yeah, we tend to think about ourselves as like the pinnacle of biological evolution. Clearly not the case. If that were the case, we probably wouldn't be destroying our planet and making it inhabitable for us and other forms of life. But yeah, maybe they're actual organisms that have like transcended their bodies, right? And they're just pure consciousness somewhere out there in the universe.
Yeah, and when I say complex organisms, I mean the amount of folds you could have in, the
gray matter, yep.
Cortex, yeah.
Yeah. Yeah, I mean, right now we don't know of anything like that on Earth. Maybe we're just missing something here. Seems possible. Okay, so it sounds like we've got a little bit of dissension about whether there's actually life on Venus right now, which is great. I guess my question for you guys who are disbelievers is, what more evidence would you want, right? So now there's going to be some kind of a probe sent to Venus to explore this phosphine gas, right? Northrop Grumman has actually been developing something called the Maneuverable Aerial Platform, MAP, right? So it's this like hovercraft that hopefully will get sent to Venus in 20, 30 years. So it goes there and explores the upper atmosphere. Do you actually need like a picture of microbial life as direct evidence, or is some other form of indirect evidence, some other type of off-gassing sufficient to prove that there's life there?
If I'm already skeptical about this gas, I feel like, yeah, I have to get something more solid than like what we consider to be like a probable byproduct. I just think that there's a good chance that something happened that we don't really understand what the heck happened. And so I think if it could happen with this type of gas, I don't see why it couldn't happen again. But I guess at the same time, if there's like a lot of different indicators that would definitely help the case for sure.
Yeah.
But if I got what I wanted, I'd love some like tangible something.
Yeah, I mean, so like having direct evidence, like a picture of microbes would be pretty sweet. I mean, the way I think about it is, as long as we can absolutely rule everything else out, and the only possibility we're left with is that this phosphine gas is a byproduct of biological life, and that's what we have to assume is creating it, right? So we do more exploration of the atmosphere of Venus and of the surface of Venus. We definitely rule out some type of volcanism that we haven't noticed. We definitely rule out some other type of off-gassing of phosphine from the surface or underneath the surface. We rule out any type of like bizarre chemical reactions that could or couldn't be happening in the atmosphere of Venus. And then we know that it has to be produced through some type of other means, not geological, not chemical. And the other thing we know of is biological, right? It's kind of like the methane gas that we have in the Earth's atmosphere. The only way to explain the amount of methane gas that we have here is with it being produced continuously by biological life. So there was a famous experiment done with the Voyager spacecraft. I think when the Voyager spacecraft passed by, it was either Mars or Jupiter or Saturn. I can't quite remember. But basically, the Voyager spacecraft looked back at the Earth and took a spectra of the Earth and discovered life on Earth from that distance away, right? So it was the first remote discovery of life on Earth. And it was the water content, oxygen, and methane. And so, I think astronomers are hopeful that if we can find similar types of biosignatures in the atmosphere of some other planet, maybe Venus, then just like the Voyager spacecraft discovered life on Earth, then we can pin it down on some other world.
Yes, I'm pretty optimistic about it. I want to believe.
You think there's life? Yeah.
Yeah.
Yeah, I mean, I would say that this is a first really good step in confirming life.
Cautiously optimistic.
I would put myself in that category as well. Cautiously optimistic. Yeah, I would want one follow-up study done by some independent researcher that comes to the exact same conclusion, that there's no other natural means that could be creating this phosphine gas, that it's absolutely the byproduct of microbial metabolism. So we'll see. And when I was just saying that, I was just reminded of another recent discovery from, I think, 2 or 3 weeks ago, about the possibility of the very first triple star system that has planets around it.
Oh, that's cool.
Yeah, so the discovery was done in radio waves with the Very Large Array in New Mexico, and a couple other telescopes confirmed it. The ALMA telescope in Chile, telescopes rather, it's an array. But their 2 independent teams found the same results, right? They found these accretion disks around this triple star system, and there are gaps in the accretion disk, which we usually understand to be planets forming around these host stars. And yet the teams came to 2 different conclusions about why the accretion disks have gaps in them. One team said the only way that these gaps could be there in the accretion disks is if planets were there, accumulating that material out of the disks, and they're actually forming there. We just can't see them yet because they're too small and not emitting any radio waves. The other team said, no, just the disturbance of the bizarre orbits of this triple star system could actually cause those gaps to form, right? So these are 2 brilliant teams that use the same data to come to the same results, and yet their interpretation, their conclusion is totally different. And so, how do we say who's right and who's wrong? Without actually seeing the planets, you can run computer models and simulations, but ultimately, each interpretation of the data is totally valid. And so I'm connecting that, back to this phosphine gas on Venus, right? You can interpret the existence of that phosphine gas however you want, and you rule out every possibility, and what you're left with has to be what's actually going on.
Until you figure out whatever.
Until you figure out you're wrong.
Yeah.
Yeah, and then that happens, right?
Yeah.
So if we look back in the last 100 years or 200 years of astronomical discoveries, sure, there have been plenty of times that we were dead wrong, and we had to revise our theories. Lots of times that we were right, but only time will tell. So
If you want to be right, you got to be willing to be wrong sometimes.
yeah, that's a good point. Totally. Yeah, and so I think these astronomers have definitely stuck their necks out there a little bit to say that they've detected possible life on Venus, but it will probably take some space probe going there to actually confirm it one way or the other. So let's make some predictions here. We're going to record this for posterity, and then we can come back in a year, 5 years, 10 years, and see who was right and who was wrong. So I actually 2 questions come to mind. So the first is the obvious one that we're talking about. Is the phosphine gas direct evidence of life? I'm going to say that it is. I'm going to wager that we understand the chemistry of Venus enough, and that this phosphine gas will actually turn out to be the first bioindicator that we get of microbial bacterial life in the upper atmosphere of Venus. That's my vote. Dave, what do you say?
I'm quite similar. Like I'm again cautiously optimistic, and there's more that we have to do, but I would say that if we send something over to Venus, sample his atmosphere, we're going to find something.
Cool. All right, so we got 2 votes for it's actually going to turn out to be life. Matt?
I have a question before.
All right.
We've talked about how we found Martian like rocks here on Earth.
Right, Martian meteorites, yeah.
So I guess would there be a possibility, like, are we saying this originated on Venus, or are we? There's really no way for us to even make that analysis.
No conjecture about the origin of life, right? It could have all originated from Earth. It could have all originated from a comet.
Yeah.
Could have been from Mars, maybe from Venus. Who knows? But just the presence of organic life.
For funsies, I'm gonna say no.
All right.
No.
We got to vote for no. And Ryan.
I'm still going to say no.
All right, we're
2-2.
2-2. All right, so there you have it, folks. 2-2, and we're going to find out whether there's actually life on Venus sometime in the near future, hopefully. Okay, so that was the first question I had. Second question is: there have been lots of reports in the last year and last several years about potential life on Mars, right? That's always been the planet that we've been looking towards to potentially find life, because in terms of its habitability, Mars seems a better candidate for life than Venus does, especially on the surface, right? So for those of you who don't know, the surface of Venus is like 900 degrees Fahrenheit. It's hot enough to melt lead, and the surface pressure is like over 100 times that of Earth. So you'd get crushed and melted pretty quickly. But the upper atmosphere of Venus, where this phosphine gas has been detected, it's possible. There seems to be some potential for habitability up in the upper atmosphere. Mars, on the other hand, is much more akin to Earth. Way thinner atmosphere, but surface temperatures like within the range of what you see on Earth. I think it can get up to like above freezing on Mars, and then like 100 degrees below freezing. But it's got a thin atmosphere, plenty of raw materials. There seems to have been like a lot of geological activity in the past with the huge volcanoes, and definitely surface water at some point from all the signs of erosion that we see. So my question is, do you think we're going to discover life on Mars first, or do you think we're going to discover life on Venus first? And you can also opt out and you say, like, you can say, no, life doesn't exist on either of these worlds. We're just trying to find what we want to find, which is a possibility.
Yeah, I think we do have this tendency to want to discover what we hope to be there, and any evidence that even slightly matches what we're looking for will fit it to our theories and stuff. I think there could have been microbial life, or definitely liquid water on Mars at one point, but currently I don't think we'll find it. I think it's an extinction wasteland right now.
So no biological life on Mars, zero.
Right now.
Okay, not even under the surface.
I don't think so.
What about these underwater lakes that have been discovered on Mars? We got liquid water under the surface.
Oh, that's kind of like what's that lake under Antarctica? Vostok Lake?
Yeah.
Yeah.
Oh. I'm still gonna say.
All right, so there isn't going to be life discovered on either of these worlds because it doesn't exist right now.
Right. Yeah.
Okay, fair enough.
Wait, so you're talking about you're not even talking about evidence in the past. You're just talking about
Right now, there's no.
Right now,
we're not going to find
no
life there.
Could have been, millions, perhaps billions of years ago, but right now.
Do you think we might find evidence that there was life at some point?
And I think we have, right? Evidence that suggests, or not life, but evidence suggesting liquid water in the past.
We know that there was liquid water on the surface.
Right.
And we now know almost, I would say conclusively, that there's, that there is liquid water underneath the surface right now, and like in large amounts, right? So liquid water seems to be pretty conducive to life.
Mhm.
But you still say no. It's totally sterile. No living organisms.
Right now, no.
Okay, fair enough. Matt?
Yeah, I'm probably in the same boat. I think like Ryan said, I think we're going to like always like I mean, I know a lot of these aren't produced by like major sites, but you'll see like new articles like every week, like this planet has a possibility, and I think we're just and it is a possibility, I think, but I think here's what I'll say: if we are gonna try to find stuff, I say we just instead of like just saying possibility, I say we just dedicate like a lot towards something that we think is like a really good shot. So Mars or Venus, and just go for it so we can stop with all this. Not stop, but like, you know, tone it down a tad, just with like all these
Tone it down.
These crazy little things that are coming out. Like, oh, we found an Earth-like planet 300,000 light years away that you know we're never actually going to be able to verify has life. But
you think so? Never?
300,000 light years. We'll never get there.
Never get there, probably.
So
I'll give you.
That's what I'll say. So
yeah.
I guess verify. Yeah, I don't know how. I don't know. I wouldn't know how to go about verifying that. Not that other people don't.
Spectroscopy, right? I mean,
again,
you do the same thing that the Voyager spacecraft did for Earth.
You're saying like put your effort into something that's more gettable.
Yeah, I think, but also even spectroscopy, right? I mean, we found evidence of phosphate gas in Venus' surface, and I'm still sitting here like, yeah. So even with spectroscopy, we're gonna have like,
yeah, there's always going to be a question,
yeah,
right? And I guess, so I mean, I'm going to read between the lines here, and thinking that you're going to still want to vote for no life on Mars either right now.
Yeah,
so we can't actually say which one we're going to discover first.
Yeah.
And so, you know, I was just thinking, so what if, here's like a hypothetical what if for you to contemplate. So we know exactly what the spectroscopic signature of life on Earth looks like from the Voyager spacecraft, and I think other space probes at this point. What if we found the exact signature from one of these exosolar planets?
I'd probably give it a lot more weight, I feel like, than.
But still, you'd be a skeptic.
I mean, I give it more weight. Like, yeah, I mean, I think it's good for. I mean, I think it goes back to me not automatically trying to like assume that we know everything about chemistry, and I think that it would definitely be, like I said, it would be a really great, probably the best piece of evidence we've ever had of life. And at the same time, at a seemingly infinite universe, I think there's a lot of room for us to be like, oh, well, we don't really understand why that is the way it is.
So you want like a message, right? Like a technosignature. You want a direct.
It's like a little Morse code light beeping on the planet.
Well, I just had one more question if you get.
Yeah. As a Dave, what do you think? Mars or Venus?
You know, that's I'm not totally sure. I mean, we've obviously got a lot more equipment and planned missions, and some in progress, to continue going to Mars and sampling the planet in more detail. That seems so we'll probably know even more details about Mars than we will about Venus in the near future. I don't know, because I don't know. I think I'm just very optimistic, and I just want something. But I think that we could find evidence of life maybe having existed on Mars. I don't know. I mean, maybe we'll find something if we have the equipment to get much deeper into the planet. We could find it pretty soon, maybe.
Yeah, I mean, there are plenty of missions to Mars scheduled for the next. Like, I think one just got launched a couple months ago, right?
Yeah.
And it gets there in 6 months or something like that. And I think there are going to be several others that go there and do just what you're talking about, like taking soil samples, drilling down, and potentially finding microbes.
Yeah, it's tough to tell because, but I mean, I feel like the signature that we got on Venus is far more strong than anything from Mars. So, I mean, if we decide to invest in more missions to Venus, we could probably find it there fast. I don't know. I'm really kind of just figuring this all out on the spot.
Yeah,
now.
well, that's great.
Yeah, I think
That's why we're calling this Astro-BS,
Yeah.
right?
Yeah. If you assume life on both, I feel like you have it be Mars first. But that's assumption.
Yeah, that's kind of where I'm going as
Yeah.
well. I think it's actually because of what you mentioned. There's just more energy and more resources going to exploring Mars right now.
Yeah.
That could shift. Maybe some big Earth-based telescopes do some follow-up research on the upper atmosphere of Venus. And in the next year or two, it becomes more and more clear that, like, wow, we don't have a single other good idea about why this phosphine gas exists, substantiated by any data except biological life. I think if we come to that conclusion in the next couple of years, resources that are currently being devoted to Mars might get diverted, and that could towards Venus. And then maybe we will discover life on Venus first. But as of now, I think because of the amount of resources and energy that are being devoted towards Mars, I think that is a likely candidate, right? And my assumption is that life is there. Not on the surface, deep underground. I'm thinking in those under surface lakes, subterranean lakes. Yeah, I find it hard to believe that if that water has really been trapped under there for any extended period of time, shielded from cosmic rays, shielded from a toxic atmosphere, I think there's a pretty good chance that life either evolved down there initially, or has been able to be sustained, having gone down there from the surface when it became less and less hospitable on the Martian surface. But who knows? I don't think anybody does yet.
One thing I wanted to ask, do we have like a pretty strict definition for a living thing, or could that evolve?
Absolutely. Yeah, the latter. We don't have a great definition of what encompasses all life, right? We even argue about whether viruses are alive or not, right? So they don't fit neatly into the definition of life that all other so-called living things seem to fit into. And so, yeah, I would say our definition of life is vague and incredibly narrow. And that will expand once we start discovering it in other places. And I really do think it's not an if, but when. I'm pretty confident that there's life someplace out there in the universe.
It's interesting to think, like, what would the headline be? Like, new life found.
Right.
Just exotic matter.
Yeah.
Behaves something like a living thing.
Yeah, maybe like it can move and it can reproduce, and it can eat, but it's got no like nervous system, or maybe it's like a
like a jellyfish, right?
Yeah, jellyfish, or it could be more like a virus, right? It requires a host. What that host is, who knows? But like maybe it's more like a tardigrade, right? These little things can like desiccate and like live in like the vacuum of space for some like obscene amount of time, and then they can get rehydrated and they're just fine. So yeah, I think the boundaries of life are probably that's our office dog trying to get in the bag of popcorn that we have. I think the boundaries of life are probably similar to the bounds that we had in the past of electromagnetic radiation. As we learn more about it, they're going to get expanded, and we will probably have a more broad definition of life in the upcoming decades. We talked a little bit about life on other planetary systems briefly. I think that's a pretty interesting one as well. Right now we know of, 4,000 exosolar planets, 4,000 planets orbiting other stars, some of which that are only 10 light years away, many of which are thousands of light years away. Matt, you brought up the fact that we might be able to detect life that's there, but actually going to those planets is probably not in the cards anytime soon. There are some interesting technological proposals to build light sails that could potentially achieve something like 1/2 of the speed of light and reach, the closest stars in a couple hundred years. But that's the closest to stars that are just like a few light years away.
And even then, you're talking with relativity, time going so much time on Earth passing while they're out that it's like
Sure.
you could send one of those and all the humans could be gone by the time it even like
that's right
gets there.
Totally. Back. Yeah, I mean, and the real issue that I think a lot of engineers and astronomers are trying to work out still with these close to light speed craft is how do you slow them down on the other end, right? So if you accelerate to like half the speed of light, and it's all because of solar radiation in one direction, then how do you slow your craft down? Do you turn it around when it's like 2 light years away? How do you do that? Like, it's probably gonna have to be pre-programmed, and like, you have to wait a year to get that message if it's 1 light year away.
How do you get out of the way of anything you didn't anticipate coming when you're going half the speed of light? That's a tough one.
That is a tough one.
I mean, we've had to redirect the ISS 3 times within this year.
Yeah,
and
I was just reading about that yesterday. You guys hear about that too?
Yeah.
Apparently, like they were under lockdown yesterday. They had to go into like the Soyuz capsule, hunker down. Yeah, so there was a big article in the New York Times about it. I think just a couple days ago, and another report just yesterday about these near collisions with space junk and the International Space Station. And so there are thousands of leftover pieces of used pieces of rockets. Unfortunately, tens of thousands of pieces of the satellites that were destroyed by the respective governments of China and India doing rocket tests on their own defunct satellites. And so these little pieces of space debris are hurtling through space at thousands of miles an hour, sometimes over 10,000 miles an hour, sometimes in the opposite direction of the International Space Station, right? So we're talking like relative velocities of like 30,000 miles an hour. And even something as small as like a little bolt can be like a bullet, at that speed. It can cause a significant explosion. And so there have been several times that the pieces of debris that we do know about have gotten dangerously close to the International Space Station within a couple miles. And so the times that have happened, the astronauts have had to basically lock down all of the airlocks in the different compartments and basically all go into the Soyuz spacecraft with the hope that the little piece doesn't hit the Soyuz spacecraft, right? Because like then they're in this like tiny isolated little pod, which gets destroyed and they're toast. But the idea is that like the probability of hitting that is way smaller than hitting some part of the International Space Station. And so, yeah, apparently it's happened several times now. The astronauts up there get this alert that there's a potential near collision, and they have to start going through this like shutdown procedure and like basically huddling in the Soyuz spacecraft until the thing passes. And the article that I was reading about it yesterday, it was a little flamboyant, and they're like, building, the tension as this like piece gets like closer and closer with the journal entries that were written by the astronauts. And apparently like one of them was looking out the window of the Soyuz spacecraft, and the other astronaut said, "You're not going to see this," right? This thing is in nighttime, right? So there's no sunlight at that point when it was going to be whizzing by, and it's moving at relative to them like 30,000 miles an hour. You don't see bullets when they're flying through the air. And so it would just happen. There would just be a collision, and they would have no idea of what hit them if something like that happened. So yeah, huge problem. I can't remember how we got onto the International Space Station.
Solar sails.
Oh, solar sails,
Yeah,
right.
yeah.
That's why we call this Astro-BS. Solar sails. Yeah, so, I mean, we could potentially create technology in the next 10, 20, 30 years to make it out to some of those exosolar planets in the next several hundred years. But as you were saying, Matt, we're talking about being able to retrieve that data in no less than 1,000 years, probably, with relativity. Seems problematic.
Yeah.
But we'll see. Maybe we'll figure out how to create wormholes, and then that won't be a problem anymore.
Or when we get there, we actually discover people that have made time machines, and then the whole time things move because we can just go back. And...
Yeah, I mean, like the whole time machine idea.
No,
like,
I know. You can only go. You know.
You can go forward in time, but I don't think we're going to figure out a way to go back. Space-time just doesn't work that way. But if you could travel through a wormhole, you could potentially come back in whatever space-time that wormhole goes to, right? We know through Einstein's work that space and time are connected. And so you could conceivably come out the other end of the wormhole in a space and time long before you actually went in the other end of the wormhole. That's why Stephen Hawking said they're impossible, because it creates those time paradoxes. But I'm not totally convinced that the universe won't allow that kind of stuff. If we can figure out how to manipulate space-time, we might be able to create a wormhole. And then go into those planets is as easy as they made it look in Interstellar. No problem, right?
You would need a lot of energy, though, to be able to do that.
To create a wormhole?
Yeah.
Yeah, I think you also need matter that has negative gravity, which is a bit problematic because we've never seen that stuff anywhere. Yeah, you need mass, you need negative mass. And we don't even know if that's actually possible. Like mathematically, it looks really nice, comes out of the theories of general relativity, but that doesn't mean that the universe actually makes it.
I think celery has
Celery,
right. That's what I read.
yeah.
Yeah.
It was like a dieting
It's
tool.
negative calories, so it has to be negative mass.
Negative calories.
Negative calories.
So you're saying that we should build a light sail out of celery.
Celery. Yeah. Just watch this in 10 years and then.
Well, that may be a good place to wrap it up for Astro-BS today. The real prediction is that we're going to have a hyperspace device made out of celery that goes to the closest exosolar planets. Matt, you want to venture a time frame on that?
It's hard to say with COVID, but I'd say within the next, I don't know, 10 to 20 years.
10 to 20 years,
Yeah.
you will see the celery star
Like, what if celery is growing on?
in the upper atmosphere.
Yeah. That's right.
All right, everybody. Thanks for joining us for Astro-BS. We hope to see you again sometime soon, every other Thursday at noon. Have a great week. And if you have any questions about any of the stuff that we talked about, you can put it in the comments section on YouTube. You can send us an email at info@wyomingstargazing.org. And if you're not already, be sure to subscribe to our YouTube channel. It's free, and have all your friends do that as well. Thanks so much, and have a great day. Take care. Bye.